There's going to be a recording of rotten oranges. So give an n to m matrix. 2 represents the rotten and 1 represents the fresh and 0 represents an empty cell. So basically every minute, if a fresh orange is adjacent to a rotten orange, the 4 directions upward, downward, right and left, it becomes rotten. Written the minimum number of minutes required such that none of the cells have a fresh orange. If it's not possible, written 1. So what is our approach? Our approach is to do a BFS search along with an extra time included in the queue, where we can note down the time while the BFS is happening and return the time when all the elements are completed, right? And if it's not completed, we're going to return -1. So that is going to be an approach. This is a pure BFS traversal. Alright, so this is the code for the rotten oranges. So as usual, since it's 4 directional, we need to BFS it, right? So we are going to initialize delta row and delta column as usual. So it's valid also as usual. So right here we first get the matrix size, right? And what you take in count is the max time. So now we're going to initialize the visited, which is a duplicate, which is supposed to be a duplicate of, not a duplicate, but an exact size duplicate of the original grid matrix. So then there is since we are doing a BFS search, we're going to store a pair inside a pair, right? There's going to be row, column and time, right? That's going to be the thing we're going to store in the queue. So for that, we need to check out the first row time. We need to, in the visitor array, we need to check it where the first rotting orange is present, right? So for that, we need to traverse the entire matrix to find that one rotten orange or mini. So if the grid size is if the node is 2, right, then inside the visited we turn that into 2. So that is going to be initial rotten orange, and we're going to push that little guy into this queue. Or if it's not a rotten, then we turn that visitor into 0. So that's how we do it for the visitor thing. So now we are going to do the BFS for that rotten shit. BFS. So while the queue is not empty, we pop out the pair and we turn that into row, column and time, right? And we're going to calculate the maximum time repeated. That's for PS. So for the BFS, we're going to check for 4 directions, right? So we pop out this node or cell, and what we do is we're going to check if it's a valid coordinate, and in the grid, if it's a fresh orange, and if it's not rotten yet, you rotten that fucking orange. You rot that fucking orange. Then you push it, right? Push the coordinate into the queue. And this goes on until all the oranges are rotten. So then you have to find out if all the oranges are rotten or not. So if the grid is fresh, and if in the visited array it's not rotten, then what you say is you return -1, because not all the oranges are rotten yet. So you return a -1 and you return the maximum time. You return maximum time. So if there is no rotten, then if there is one, if not all can be rotten, you return -1. If, bro, what am I saying? If all oranges can be rotten, then you return the maximum time. If not all oranges can be rotten, then you just return -1. That's how it goes, and you sum it, right? So it's gonna be n into m. So n is the number of rows and m is the number of columns in the. This is the time complexity, and this speaks complexity for the visit minus n to m. That's right.